As a second item of part 3, let's try cryptanalysis. The goal of topic 2 is to learn key programming techniques, and we have learned major techniques. So for reviewing these techniques, why don't we try out our hand at making a program for cryptanalysis? In this lecture, we discuss the basic idea and outline of the program. Then the details will be explained in our practice exercise. Let's start with what cryptography is. Cryptography or cryptographic communication refers to the communication encoded in such a way that you cannot tell what the content of the communication text is, even if you see it. Let me explain the basic story or flow of cryptographic communication. Basically, 3 characters are involved in cryptography. First, we have a sender who sends encrypted message, then receiver B of the message. Furthermore, we have eavesdropper who eavesdrops on the cryptographic communication. Let's call him agent E. Those are the 3 characters. There must be a text that the sender wishes to send to B. Such a source text is called a plain text in cryptography. On the other hand, once we encrypt that, it is called ciphertext. Creating a ciphertext from a plain text is called encryption. Then this ciphertext is sent to B, receiver B. Upon receiving the ciphertext, receiver B restores the ciphertext to the original plain text. This is called decryption. This is the main flow, that is, first encryption, send, third receive, and fourth decryption. Furthermore, there may be someone looking at this ordinary communication. We will call him an eavesdropper. In cryptography, we usually consider the worst-case scenario. That is, we assume that he was able to get this ciphertext completely by some method. Even in this situation, we want him not to obtain any information on the original plain text. Note that cryptography is used not just for communication, but also for storing data. So cryptography and encryption don't necessarily refer to communication, but rather, in general, to encoding such that text is not understood, even if it is seen. Let's look at this basic flow in more detail. Considering this using functions should provide some clarity. As our example, let's consider Caesar cipher and discuss what kind of functions are needed here. First, we need a function for encryption. Let's name it enc, E-N-C here. The encryption function enc takes 2 arguments. That is, the encryption key K, which reveals how many letters to shift by, and the plain text M. Then it provides a ciphertext for M, which is obtained by encrypting M, in other words, shifting it by K letters in the alphabet. In contrast, a decryption function takes the encryption key K and ciphertext C, and then decrypts C by shifting K letters reversely, thus providing the plain text for C. Recall that our challenge is to make a cryptanalysis program. Let's clarify what it is. Here again, consider the basic flow of cryptography. Cryptanalysis is what agent E would do. Remember, we assumed that eavesdropper E was able to get the ciphertext completely by some method. Cryptanalysis is computing the original plain text based on this. Again, let us specify the task of cryptanalysis precisely as a function. This is it. This function analysis is what eavesdropper E wants to compute. Note that this value is the same as the function dec. The difference is their arguments. While DEC has two arguments, that is, the key k and the ciphertext m, function analysis is given the ciphertext only. This is the difference between decryption and cryptanalysis. Eavesdropper E must obtain m without knowing the secret key k. We assume that eavesdropper can get the ciphertext completely, but we also assume that he cannot get the key. The eavesdropper needs to compute the plaintext without knowing the key. Writing the goal of computation with a function reveals this difference. Let's see some example. Here we use 3 for the secret key. For example, shifting 3 letters turns the plaintext good into GRRG. We got this because the uppercase letter G did not shift. Now, if we take this one and then reverse shift by 3 letters, the corresponding text is good, GOOD. In contrast, with analysis, we want to take only the ciphertext, compute the plaintext. Let's consider a program that creates an actual ciphertext. Let us call this program encrypt.rb here. This is a program that the sender A would use. What we want for this program is, for example, like this. When running the program, it waits for us to input a plaintext. And for example, if we type GOD and press the return key, then it encrypts this given plaintext and yields the ciphertext GVK. Here, the parameter k for the number of shifts is kept secret within the program. Here is the outline of the program. In this program, we first define the encryption function enc as a subroutine. Recall that we created the program enc.rb for doing this task, so we can use this program here. Once subroutine enc is defined, the main program is rather simple. First, we will decide what k is. This is determined between sender A and receiver B in secret and specified in the program. Let's use 7 here in this example. Then we will read the plaintext. We read in the string with gets.chomp and store it in a string variable called plaintext. Then we will turn the plaintext into a ciphertext with an encryption function or subroutine enc and store it in a string variable named ciphertext. Finally, we will display that on the screen, this one on the screen, by using the puts command. Now consider a decryption program. Let's call it decrypt.rb. This is a program that receiver B would use. Here is the outline. As you can see, the program is symmetric with encrypt.rb. I use the red letters to highlight the difference. Please compare them by yourself. Note that we should use the same value for the variable k, that is shift number. We consider the details in our practice exercise. Here, let's assume we have these programs. Then we would use them in the following way. The first sender A prepare a source message and keep it in a file, say message.txt. Then use the program encrypt.rb to create a ciphertext, which is kept in a file, say cryptomessage.txt. As we studied in the earlier exercise, this can be done using redirection. So this is the execution of the program, and then from this file, you get this program gets a message, and then output the message is put into this file. After receiving the file, cryptomessage.txt, receiver B would use the program decrypt.rb to get the original message like this.